Algebra 1, number 3.8, we're going to talk about equations with absolute value in them. We're going to solve equations containing absolute value. So the absolute value of a number is just its distance from 0 on a number line. It always equals a positive or 0. It never equals a negative. So this is read as, when you see these two long lines like this around a number, the absolute value of negative 5 is 5. That's how you would read it, okay? When we see the two absolute value bars around a number, it's asking us how far that number is from 0. How far is this number from 0? It's 5 spaces. You know, look at the number line. Here's the negative 5 right here. It's 1, 2, 3, 4, 5 units away from 0. See? So it's not negative 5 numbers away from 0. They want to know just how far away it is, okay? So they don't care if it's negative or positive, all right? So in here it could be negative, but after the equal sign, it's got to be a positive or a 0 after this equal sign once it's outside these bars, okay? So because a distance can't be negative, absolute values can't equal a negative. So if I said my dog walked a distance of negative 5 blocks, it doesn't make any sense because even if he walked backwards, he still went 5 blocks, right? He'd have to go in a black hole to go into a negative distance, right? So remember to check this video's description for links to similar and helpful videos, okay? There might be more about absolute values in there. The absolute value of n equals 5. That's how we would read this. The absolute value of n is 5. Now, n could have originally been a negative 5 or a positive 5. We don't know. All we know is that it's 5 units away from 0 on the number line. That's all it's telling us. So the absolute value of n could be a negative 5 or a positive 5. And we can check it by putting a negative 5 in there. And the absolute value of a negative 5 is 5. That's 5, so that works. And the absolute value of 5 is 5. It's 5 units away from 0 on the number line, okay? If we have the absolute value of n plus 2 equals 12, we can use the addition property of equality to create a 0 pair to isolate the n, can't we? We can subtract 2 from each side, and that'll create a 0 pair right here and get rid of it. And then we subtract 2 from this side, and we get a 10. So now we know the absolute value of n is a 10. But we don't know what was originally inside of here. All we know is that it's 10 units from 0. This could have been a negative 10 or a positive 10. So we write that the absolute value of n could be a negative or positive 10 because we don't know what it originally was. We only know its distance from 0. And we can substitute it in to this equation, the absolute value of n plus 2 equals 12, to see if it works, and it does. So we know it could be a negative or a positive in here before we found out that it was 10 units away, all right? So just remember, I know it's really confusing. Once it comes out of the bars, it can't be a negative. It can be a negative inside the bars, but once it comes out, it's not allowed to be a negative, okay? All right, let's take a look at this one. We've got 3 times the absolute value of a minus 4 equals 2. So what I see right away is we can create a 0 pair, right? We can use the addition property of equality right here and add 4 to both sides so that we can get rid of this minus 4. And we add the 4 to this side and get a 6. So now we have 3 times the absolute value of a equals 6. Now we can use the multiplication property of equality, and because this is no different than a variable, this a is a variable, isn't it? Even if it's an absolute value bars, it's still just a variable. So this is the coefficient to it. The 3 in front of it is the coefficient to that variable. And using the multiplication property of equality, we can flip this coefficient around to its reciprocal, its opposite. So instead of 3 over 1, it would be 1 over 3, right? Remember, reciprocals are just flipped around versions, right? Okay, so we do it on both sides to be fair because we want to keep our equation balanced, right? And we get 3 over 3, which is a 1. That's our buddy that's going to turn into the invisible 1, isn't it? Over 6 over, and then we've got 6 over 3 on this side, so that's a 2. Now, we don't know if a was originally a negative 2 or a positive 2. All we know is that it's 2 units from 0 because it's on the outside of the bars. So for this one, the solution is positive 2 or negative 2, all right? So remember when you're doing this to say that it could be positive 2 or negative 2. We don't know what this was. We only know after the equal sign outside of the bars that it says it's 2 spaces away from 0. That's all we know, all right? What about this one? It's got a fraction. We've got 2/5 times the absolute value of b plus 2 equals 5. We can use the addition property of equality to create a 0 pair right here, can't we? We can take away 2 from each side of the equal sign, and that's going to give us 2/5 times the absolute value of b equals 5 take away 2 is 3. And because this 2/5 is the coefficient to that variable, even though it's an absolute value, it's still the coefficient to that variable. What we can do is flip this around to 5/2 and multiply both sides by it using the multiplication property of equality, and we'll make our buddy the invisible 1, that identity property, right? So now we got 10/10b, and that's our 1. So it's just the absolute value of b now on this side, because it's times 1, and identity property says that stays as it is. It doesn't change its identity. On this side, we've got 15/2. Now, we don't know if this absolute value of b was a positive 15/2 or a negative 15/2. All we know is that it was one of them inside of these bars. Once it came out, it was 15/2. See? All right, so remember, when inside the absolute value bars, you can have a negative or a positive. What it equals can't be negative. So inside it can have a negative sign. Once it comes out, it can't have a negative sign. All right? And there's a video link in this description for video 2.1c from this playlist that talks about absolute values way back in the beginning, okay, in chapter 2. I hope this was helpful. We're going to move on to 3.9a, and we're going to talk about proportions, all right? I hope you're doing okay. Keep your chin up. Don't forget I'm on Twitter, and don't forget I'm on Patreon.com. And if you become a monthly patron on Patreon.com, we can actually talk to each other, and I can help you more, all right? See you next video. Bye.